Okay, for number 14, we're asked to make a brief table of the values of t, x, and y for these parametric equations here, where t goes from -3 to +3. So I've made this table with different values from -3 to +3, and for each of these values of t, I plugged them into the x equation and the y equation, and I made this table here. So we can, in this table, we can visualize the relationships between t, x, and y for different values of t. So we can put a check mark for item A. Now for item B, they want us to plot these pairs, and they want us to indicate the direction of the curve. So we are going to plot these, and I'm going to make the scale a little bit different here so that we can draw everything comfortably. On the x-axis, I'm going to put a scale of 10. So it's going to be 10, 20, 30, -10, -20, and -30 is going to be a little bit further down, -30. And on the y-axis, I am going to put a scale of 4. So 4, 8, 12, 16, and same thing here, -4, -8, -12, and -16. Okay, so once we've put in our scale, we can now go ahead and plot these. So when t is equal to -3, we're going to have that x is -28 and y is -14. So -28 is going to be somewhere here, -14 somewhere there. When t is -1, x is going to be -2, y is going to be -4, so -2 is about 1/5 of the way, and -4 is here. Actually, I think I'm going to plot these points in a different color so that we can see them clearly. When x is equal to -1, so even closer, y is going to be equal to +1, so we're going to have maybe here. When x is equal to 1, sorry, when t is equal to 0, x is -1 and y is 1. When t is equal to 1, x is 0 and y is going to be equal to 6, so somewhere here. When t is 3, x is going to be 26 and y is going to be 16, so like so. So our curve is going to do this, that, here. And then I'm just going to label some of these points. So this is when t is equal to 3. This is when -3. This is when t is equal to -2. This is when, sorry, -1. T is equal to -1. This is when t is equal to 1. And this is when t is equal to 3. And the direction of the curve is it's going to go in this direction here. So that's it. We have drawn the curve, right? So we can put a little check mark here. So for item C, they want us to eliminate the parameter to obtain an equation in x and y. So what that means is isolating t either in terms of x or of y, and then plugging in that value of t into the other equation. So the easiest way to isolate would be in this equation here. So that's what we're going to do. So we have that y is equal to 5t plus 1, which therefore means that I'm going to bring the 1 to the other side. So y minus 1, and then divided by 5 is equal to t. So I was able to isolate t in terms of y. And now I'm going to take the second equation that we're given, x is equal to t cubed minus 1, and I'm just going to plug in the value of t, but now in terms of y. So we get x is equal to t cubed, so y minus 1 divided by 5 cubed, and then minus 1. So this over here is the parametric equation where we have a relationship between x and y, and we have eliminated t. But we're not done yet, because we can see that the parameter here has restrictions, right? The curve doesn't go on infinitely. So we need to also express that restriction in terms now of the input. And we can see that we're treating y as the input, so we need to restrict y so that this curve doesn't go on infinitely. So y, from our table, we can see that y goes from minus 14 to 16. So this is the entire range of y, and we can see that y takes on every single value in this interval. So we're just going to say that y is less than or equal to 16 and greater than minus 14. So that's it for item C. We are able to express the curve in terms of x and y. And now we just want to describe the curve here. So we're going to say that this is a cubic function, right? It's a sideways cubic function. So a sideways cubic function going from the initial point, which was minus 28, comma, minus 14, to the final point, which is 26, comma, 16. So that is it for item 14. We described the curve and we did everything that they asked us to do.